Welcome, I'm Bill Wake. We're here working on a programming language called 10th. That's a sort of subset or something relative to 4th. And we did the compiler and interpreter, and now we're working on writing a hangman game to demonstrate that we can use the language. And we've demonstrated that we can find some bugs. So we've got some weird interaction where if you run the same test twice, it fails under some circumstances. So I think well, let's try and characterize that a little bit. I think I've noticed a pattern though. Let me show you that first. So let's pull this code in. Okay, and the problem we've been having is this test update clue. It creates a 5-letter word, and I'm wondering if there's something going on with the number of letters. All right, so let's run that. We got a bunch of print statements in there. The place it failed before was somewhere like there, but I think it will fail if I do it again. All right, let's. Boom. Okay. So, well, that makes me think. I think we need to do some actual debugging. So, and the thing I think will be helpful is something called the Saff squeeze. And the idea is you basically inline code into a failing test, and then as you inline it, you can start cutting out stuff. Like if you find the test fails halfway through, then the stuff after the test failure is meaningless. You can delete it, and eventually you'll come down to something that's pretty small and wrong. And if you, given that knowledge, you can probably create a test that directly demonstrates that. So I think the way to do this, let's make a new file. And it's just an empty, okay. I'm going to call it debug.10. Oh, and it's also in the wrong directory, but we'll live with it. All right, I don't even know if I'll need to check this in, but I'm going to copy everything. Okay, so now we know this second test fails if you run it twice. So let's just run test 2 is this twice. Okay, and take all that, copy it, run the REPL again, and paste it, and with any luck, test 2 will fail. Good. Okay, so notice the failure we have. Well, here's, okay, it prints its own name first, and then it does a bunch of stuff. This one printed its own name the second time, called game init with canal, which is right. Found the answer, same value before S2A and game init. But we didn't make it into the call. So it's a little weird. And also it's going to be a little weird for this inlining thing, right? Because we're running the same code twice. So we can't just delete half a method and expect it to be okay. But we'll start in the test. All right, so this other letter match, this test. All right, let's take out all the assertions and this buffer word and see if it still fails. Okay, and we can, we'll just run this one test. Oh, I guess I need the whole thing anyway. Make REPL. Okay, and now we run test 2, which is only calling less, but okay, this is good news. So our assertions are not contributing to the problem. All right, so let's take those out. Okay. I'm just going to bounce back and forth doing this. Oh, we haven't run test 2. Okay. Boom. Good. All right. Now I'm going to inline this into test 2. So let's do this. If we did this twice, that should be the same thing. All right, so let's copy that. If it weren't crashing, this loop would go a little faster, but all right. So now test 2 hopefully still fails. Good. All right. So we know it didn't fail the first time, so I'm going to copy out, comment out this one. Okay. Paste again, run test 2. Okay, so that's suggestive. Now, what it makes me wonder is if this one matters. Like, is it an update clue problem or a game init problem? And so it could be a problem with game init running twice. It could be a problem that game init works, but this screws up something and then this fails. Okay, so let's take this one out. Okay, well, that's interesting. So game init twice fails. Wow. All right. Now, let's see if we can inline game init. Well, he's got a lot of stuff going on. Well, we don't need the definition, just this. Okay, so take this out, this twice. Okay, well, I'll leave the prints for now. We'll do it small and safe. Okay. Okay, now this is different. Yeah, most of that is debugging output, but something's weird, right? I mean, before it was printing, I don't know if I can go back that far, but it printed out a bunch of stuff the first time through and then failed on the second. And now it's failing on the first before it calls anything. Something's really weird, right? Because test 2, first thing it does is it prints something and it's not getting that far. So I don't know if I should. It makes me wonder if there's something lower level that's messed up. I hope not. All right. Well, let's do it again just to make sure we're repeating this. Now, isn't that weird? Oh, game init, we didn't pass canal in. Before we did canal game init, so let's do that here and here. Oops. Canal game init, okay. Yeah, so these subtle clues, definitely worth watching. Okay, test 2, boom, good. All right. Oh yeah, you're on the same page. Yeah, okay, so same failure. So that tells us the inline worked. Okay, so now, well, it's dying. This says before S2 call the second time. So it did this one and then it died here. This line is, I believe, yeah, it's right in here. Okay. No, I'm going to take the prints out on the upper one because we know we're getting through that. Okay, so wrong guesses init. The answer looked okay, right? Answer is, that's the variable. Okay. I mean, it looks like a memory address. It's the same number, which it should be because it's the same constant or same variable. All right. Now we can't take off this. Oh, we could. Right? We can theoretically take out this stuff because it died before it got back. So I'll just keep out most of it. Okay, because we gotta find a way to cut something, and the closer we are to half, the better. Get that binary search going on. I'm not the best debugger in the world by any sense, but we can do these. I'll do what I can. Okay, so now game init canal. I still had prints in there. Oh, our other stuff. S2A has some prints in it. Okay. All right, now I don't think it's related to our guesses init thing. Because that really is kind of independent. So I'm going to take that out. Now, dupe answer dot. Well, it should be a string. Then we can do a dollar print answer. Okay, we pushed answer on. Let's do this instead of pop like that. Okay. So I took out the wrong guesses in init, and I changed what we print slightly. So we'll print the string instead of. Oh, but wait, answers a string. Okay, we said it was, so I guess I'll trust that for now. Where's answer? Answer equals C. Well, that's odd, isn't it? Yeah, wrong. We added that to fix some other issue. Well, I guess we had to put the initialization somewhere, and we thought we'd put it in the big game init. Okay. Is that wrong? Okay, so canal goes on. We print game init. We print the top of the stack should be canal, right? Game init canal. We duplicate it. Now we got the string on there twice. Answer equals dot dollar dot. Answer is not the same as the. What is answer? Now I'm a little puzzled there. Okay, canal, we got the string. I'm pushing answer. I'm gonna write the answer into string to array. So answer is the array. I haven't called string to array yet there, but here I have. So if I were to look at answer answer make dollar print and pop. Okay. Let's try that. Make sure answer's right up here. It should be CANAL, one per array entry. Make dollar should turn it back into a string. Okay, so answer is C. What is it up here? Where am I printing it? Only down here. Well, oh, but I'm printing it here. I didn't print a header. Do we see? Let me print a lead into it. This is test 1. Okay, that'll call a little more attention. All right. Now I do wonder if we can get rid of the length stuff. If it's the deal is it writes the answers into an array and then it writes the underscores into another array. All right, so test 2, we should see test 1 with something canal. Okay, so the word did get formed correctly there. All right, now I'm wondering if I can get rid of this stuff. String, string, string. Okay, so if I got rid of this, all right, now I have a string on there, I better pop it. Okay, so that's my way to get rid of all this stuff. It started with a string and it used to do the array repeat thing and now it doesn't. Okay, let's take this line out. Okay, I was worried maybe it didn't write it correctly the first time through, but okay, this is kind of a moment of truth thing. If we can get that, okay, good. So this goes away. Answer swap puts string and answer. I don't know. Well, I think we can get rid of this one because we don't do anything with it at this point. Canal dupe. Answer swap. Okay, the only reason to dupe is so we can get it there later. So I think we can take this line out and this line out. And I think that until we call string to array, this isn't meaningful. This is probably more meaningful there than that is. Okay, well, this is good. All right, canal answer swap is really the same as answer canal. We took that string off and that string off. Okay, so we're getting the front stuff out of the way. Okay. I think we could say the same thing here, string. We don't need that last string, so let's take the dupe out. that takes this out. We're honing in on string to array, I guess. But something's trashing something. Okay, well, let's pull the same trick here. I don't think this game init thing matters. Let's just do answer canal. We don't need to do the swap now. Okay, there's the critical call. So calling string to array twice is suspicious. Okay. It is, I don't know. That's a possibility. Well, I don't think so though, because answer, it's writing a word of the same length. I mean, I could believe there's a problem if they're different lengths, and I sort of assumed that was what the original problem was, because the short words passed and then you did a long word and it got screwed up. But when we ran the same one twice and mess it up, I mean, it suggests there's some state that's going from string to array, but like notice this before S2A call and game init, like something is really weird here, because string to array, let's find that. None of these are recursive, so there's no reason we can't pull them all in. All right, so string and array pointer. See, his index says he's going to go from 0 on. So I think that's being reset there. And then the array string thing, we swap in. I don't know. It's kind of funny. We're doing a swap first there. It seems like we swap to get it in order and then swap it again. Okay. Okay. So what puzzles me is, and this is the puzzle we've had the whole time. So I call S2A started canal, and then somewhere I call before. Oh, I dropped the before, but I'm in S2A at this point. What's created before string to array that can overflow? Yeah, that's a good question. Well, nothing. Although this would be easy to mess up because it's a pointer to an array. The name doesn't really reflect that. Yeah, I'm looking for variables. There are no variables before these two. Now, I'm going to take this length printout out. Let's see who calls string to array. Game init, which we've already inlined in there. Okay. Well, let's inline. Right. So I guess the thing that's weird to me is string to array prints before it gets into things. And this thing calls this right before it calls that thing, but it doesn't do its first line printout. So that is really weird to me. All right, but we will inline it. I guess if we took this stuff. Okay, so this is string to array. And it takes a string on top and then an array, which I think is what we have. Okay, so game init now. do our stuff. Okay, here's test 2. All right, so string to array, put a little marker here, is this stuff. All right, so that should be that. Okay. And then same thing here. That. Now, I feel like maybe this will make it not happen. Yeah, we could change it. I know we tried a short word. I believe we tried like a 3-letter or 2-letter word. The other one that's in my mind is when we write strings, we round off to go past, so we go past the string to start the next word. So it starts on a 64-bit boundary. Canal is still short enough to be on an 8-byte boundary, but I don't know if there may be, if somebody forgot to count a character for the null string, the null byte at the end, or I don't know. But let's take this, see if it still blows up. This is the inlined S to a string or string to array. Okay, test 2. Haha. Yeah. Okay. This is very weird to me. It's also weird to me that answer equals C. Okay, so let's look at these variables we have. Well, it's working, so I guess it's not a big deal, but how could we be messing up that? Okay, yeah, let's let me undo these changes because it didn't make it fail. Okay, make sure this still goes, make sure it still fails, then we'll try a shorter word and see what happens. But I think we tried well, let's try 4. So fish works. Let's do it again. That could well be that we're writing, I mean, it's supposed to be a pointer, so a pointer to an array, and it would be easy to get that confused at some point. All right, so fish creates no problems. Let's change it back to canal. Didn't know I had a aquatic theme going. All right, I'm just going to overwrite this test. Boom. Then that seems like a different kind of problem. Well, I called it sort of 2, 4, 6, 8, but I can do it in here multiple times too. Did I get everything? Okay, so 4 characters. Like, I don't know why that would. It's 12 bytes plus 3 bytes for the null bytes, so it is 15, right? But the 5 is 15 plus 3 is 18. They're both more than a word. Yeah, it's bizarre. We can go look at the code and see what we think. But something is so weird that, the weird thing to me is sorry, let me go back down. Okay, when I call canal, and we'll just leave the 3 in here, 3 runs. Okay, so it does all that. It prints a bunch of stuff. It does answer canal. It prints the before. The next thing it's supposed to do is call this method. And string to array, the first thing it does is prints. With this stuff up top. Well, that doesn't need to do dupe. You can just print and not delete it. Okay, but regardless, so how do we know this guy's going wrong? Well, when we get down here, there should be 3 character and a string, and maybe more. All right, so post loop dot $arrow print 3. Okay, so I would expect to see a character, a string. Well, maybe that would be better to. Let's print the top, and then we'll do a swap, and then print as a string and do a swap to put it back. Okay, so print, oops, print post loop, print the character reputedly on top, which should be a 0 because we're exiting the loop. Swap the C and the string, print the string as a string, swap it back so C and string are there. Okay. Make sure before I commit too much to it, make sure it's still failing. Okay. I believe it is adding the 0. Now, as to array. It's storing the 0 at the array. Yeah. Okay. I don't know. It looked okay. Other than not working. It seemed to work on the individual tests as we ran them. So it was only running this bulk test that we found that we crashed on one of these. But I am just totally blown away. Okay, so you're right about the pointer that there may be something we're doing wrong there. So S2 array is really the pointer. Like, you give us an array, and we're going to store the address of that array in S2A. So the value you give us is what gets stored. Is that the right pointer? Maybe. Okay, so we clear S2A index, so that's fine. I guess the problem could be if we're writing into S2A array and that value is not the right array, it could be trashing the code for this. And when we come back in, who knows what got overwritten on this stuff. Um, I kind of hope it's not that. All right. How do you call it? Okay, let's inline it once. Well, no, I think we've changed things enough. Maybe let's run it and analyze the stuff we're getting in it. Test two. Okay. S2A started canal. Where's that post? There it is. Post loop 0. Wait a minute. Post loop should print a string. And the number. Sorry, it should print the number and a string. But then before S2A call. So the string is empty at this point, apparently. Print S2A array before each usage. Yeah. Okay, so S2A array. So this is a debugging thing. S2A array dot pop. We don't have an automatic pop on the plain old dot. Load the array back up and print its value. And then here we, S2A at. Right, because we need the thing it points to should be the array we gave it. All right, do we always do S2A array at? Let's check that. S2A array at. Well, that's suspicious. So you want to see S2A's address, S2A array's address, or the address of the array we passed in? This is very suspicious to me, though. For all that, I think we're overriding S2A array at this point, which would fit the problem. Okay, let's try this. I don't think we've changed anything up here. We added an extra print somewhere, but pass, please. Yes. Okay. Oh my goodness. All right. Well, let's try a long string just to be careful. Onomatopoeia. I just kind of want to be sure there's no string count problem or something like that. So a long word might reflect that. Okay. All right. I think we have it then, because it explains anyway. It's a reasonable explanation. Because we didn't do an at down here, we were writing the 0 byte at the index. So I think our index is the length of the string. So maybe if it trashed the first 3 characters, it didn't hurt anything. But if you come down here, you're trashing the 6th character, which, well, yeah, our header, right, is 3 bytes header and then the body. So I don't know if you're on the 4th byte, you're out of the header and into the body. And so you're trashing this code with who knows what. Well, with a 0. And referencing that would be give you a 0 reference and a reference fault. So I think that explains it. Because, this is pointing right. Where's S2 array here? We accessed off it, and that's into the body of this because of the way we lay things out. So, whew. I hate scary bugs for sure. Okay, so let's put it back to a simpler test. I don't need the third one, don't need that. Okay. And this is not, it's not so much test 2, it's test calling string to array multiple times doesn't crash. Okay, so this is a test for the defect we encountered. I'll put it here, move this up. Okay. And this can come down. All right, I guess that one can go up. All right. I'm going to run this, make sure it passes, take out all those prints. Good. Annoying, but good. All right. So yeah, let's get some prints out of here. So let's find ... Okay, and then $arrow. String to array. We're going to take this one out. Yeah, so that would have trashed before it had a chance to print. So that's why it apparently called into it, but didn't do anything. Okay. Lengths, we don't need. Okay, let's see if we got this thing quiet now. Nope. Test update, game init. Oh yeah, game init has a bunch. Okay. So I think, well, it's unfortunate we have the problem or had the problem, but I think that's a reasonable demonstration of what that Saff technique is, that, that we're inlining stuff. Whoa, what's this? That should be right, I think. Oh, I'm editing the debug. Okay, well, we'll put this. Let's see. Let's make sure we're there. But anyway, a good demonstration of that technique, that eventually you're inlining enough, you're going to hit something. Now, we hit something that's on that level between, the problem we had was not a high level language problem. It was kind of the interaction. If the variable for that thing had been located far away, it could have been trashing something else and nobody would have been any wiser. But I like that inlining technique. It's especially nice if you have IDE support, and as you inline, eventually you may hit recursion or something that makes it pretty ugly to deal with, but a lot of times you don't. And that's pretty good. You pull in this code and you find the thing that's going wrong. Okay, so that's good. All right, so now let's take this, write it over this. Okay, and then delete this. Sorry, test it and then delete it. See, that's hangman.10. Okay, make rebel, do this. Now, test update clue. Okay, good. All right, this goes away. Okay. All right, so I think we can say HTTP fix defect where S2A array got used as an array reference rather than a pointer. Okay. Well, could be worse. Where are we to do? Okay, so we fix this one. What do we call this? Debug test interaction. Well, update clue was a distraction. It was string to array. Used a pointer as an array. Okay. All right, now what we set out to do, guess a wrong letter, update the used letters list. Okay. That was why we moved game init in there. All right. Yes, so update. Okay, let's update clue wins. Okay, yeah, but this is the new thing. I think it's a little different than that, so I'm going to do that. Okay, so does this pass? Test update wrong guesses. Fish game init, make a wrong guess. Wrong guesses make assert equals. Update wrong guess. Store the character in the list of wrong addresses. Okay. Wrong guesses index. swap it around so we have character index and wrong guesses. Write the character to the current index. And that's that. Okay. Yes, we are. Update wrong guesses. This. Okay, so let's run it standalone just to make sure we're okay. Good. All right. So, oh, what we don't do, well, oh yeah, we were going to make where is it? Update clue is going to return a boolean, we said. And I don't think we really check that. We leave it there. Where's the bool result? Character answer, character result. And this just leaves result. And this is character answer. No. Do character answer, character result. Okay. So we need to check update clue. Are we checking that? Oh yeah. Okay. Oh, maybe this is where we left off. Test update clue, other letter match. Oh, we deleted all those assertions. I think. I'm not quite sure where we left things. Let's... Well, let's see what it should do. Clue make should be blank A for canal. Game over should be 0. The result is yes, you did find it, and we took out 531, 531. And that is test update clue other letter match. And that's in here. Okay. Good. Okay. So, yeah, I think we're approaching the game. But I would say we should do some UI stuff. So let's find that picture. Here we go. Right. So we're supposed to have the wrong guesses on this list. I think not all of them, just the wrong ones. Okay. So, and I don't know about the spacing there either, but we'll live with it. So let's find we had here's the hangman. I think we want wrong guesses to appear in here. Okay, so I can say wrong guesses. The scaffold's at 6. 6, 7, 8, 9, 10, 11, 12, 13, 14, maybe 15. Yeah, I think that's right. Let me put this in. 15. We'll do it at 25. Draw at. Okay. Okay, I think that's all right. Maybe he should be over a little bit. 1, 2, 3, 4, 5 columns over. I can just paste that one. Something's wrong. What did I change? Scaffold. 15, 25. Okay, I still want to move this left, maybe 4 characters. 15's the row. This should be 20. Do 5. Okay, yeah, I think that'll look good. As good as you get. You think a little more? And they're going to have a space, and then they're going to start writing their letters. They might get this far. I don't know. That feels a little balanced. You only get 10 guesses, right? So, and that's counting hands separate from arms. Okay. But the thing that's not there, right, is this wrong guesses, the actual wrong guesses array. Now, where is that? Oh, we put it all together. Okay, so, I mean, I think what I'm saying is wrong guesses make $35, 1535 draw at. Okay, and yeah, well, it won't matter yet. This is kind of the pure drawing part that I'm not going to try and unit test. Paste this, hangman. The list is empty, so it's not going to do anything. All right. Ideally, I would like spaces between them, probably spaces between the underscores too, but we will. That's definitely on the aesthetics point of view. Okay. Let's see. So what is next? Guess a wrong letter, update the used letters. And I guess, did we establish that? Wrong guesses has the letters you add. Okay. Well, let's add a couple. 97's A, 99 is C, and 100 is D. Okay. So this should be AC. Let's put them out of order. A, D, C. Just say they're in the order that they were written. So nice one. It's not crashing all the time. Okay, test, update, wrong guesses. Okay. All right. So what we've got is, yeah, exactly. Something that adds that in, or we are printing these from the arrays. We don't have an array, number to character thing. So yeah, something to do it. Check wrong guesses, keep letters, and make hangman print wrong guesses. Okay, so even though we don't have the drawing stuff, right? I feel like the pieces are there now. We've got something that will, if you read a guess, we take it and we could run it through update clue, and it would add it to the answer thing if it could, and if it can't, it'll return false, and then we could call update wrong guesses with that same thing. Okay, so we don't have that overarching piece that keeps track of that. And let's see. So I think this is done. We kind of did it the other day, but yesterday. All right. Body parts, I'm going to wait. Okay, so, I mean, it's not Hangman without them, but it's not a game yet either. So I'm going to try and make the gameness be coming through now. Yeah, you can play without the drawing. So, well, print guessed in wrong letters. Okay, we've actually done that too, I guess. Here. Okay, but this game loop thing, and this you mentioned the other day, and I kind of pushed off like, oh, we don't need to test. We don't need a mock to do this, but we should really for this game loop, because the game loop is going to be the thing. I mean, it's really like while not done, read a character from the keyboard, process it. And process it is, try it as a clue. If it fails, do this. If it succeeds, do that. All that kind of stuff. So that definitely can be checked. Now, the tricky part is do we want game over to really work? And we definitely don't want read to work. Okay, so let's work on the game loop. All right. So I think I want to use the real not done thing. That just means we have to fill it in with this. But it's an end-to-end test. Okay. So this thing. All right. So it's calling everything, so I got to keep it below most things. Oh, maybe we should refactor the tests out first. We haven't moved those over in a while. Okay, and is this in a test empty answer? No. I guess we should have test answers, or we should put it with all those others. Let's move these down. Test empty answer, test string answer. Okay, make sure we move them properly so far. Okay, and then test update clue doesn't blow up. Good. And now let's pull tests in. Okay. And test all. Okay. So I do want to add. a new line here. Okay, and this was a test update clue. I know that word doesn't come out of my fingers very well. All right, but let's move these over. And we're calling test update clue. Okay, so let's kill this, run it from scratch, because I really want to make sure I've moved things properly. So we'll want to check the compiling. All right, I don't see any red. Because when you move functions around, you definitely risk that you make a compiler mistake or a syntax error. Because they have to, they can't call recursively, they must call a predefined routine. Okay, I think we're on the previous one. Yeah. All right. That was the main. Let's do the tests. Okay. Didn't see any. Okay. Right. Okay, so we're getting a pile of tests. Good. Okay, so ACP. Good. All right. So now we're going to do game loop. Okay. Now this. Okay, so test game loop. I don't know what the test is. Well, I guess we could give it a short word, get one wrong guess, one right guess that finishes the word, and we should return and be happy. Okay, so the game loop, so the inputs for this thing, we need the routine, read routine, and the answer, and this goes to nothing. Okay. So I think the test is, well, we're going to do a game init. Well, let's store this var game loop read is a string. Let's put that up here. Okay, so the test, let's do, well, maybe go to or however you say it. We'll game init, and then we'll call game loop. We need the routine. I guess stub, right? So is that the right terminology? I always get confused. I'm writing about it and I'm still confused. Stub stubs generate values that you need, I think. If I get it wrong, let me know. All right, so we need a read stub and we'll need to initialize that. Like somehow I think this should be the initialization for it. Read stub. Contents. Maybe this is not a good way. Well, let's keep writing until we get there. Okay, so this thing has to get read stub quoted. Okay, because our call mechanism needs a string version of the read routine we're going to call. And then at the end, let's just check that the stack is right. Go. Now, is that enough? I guess we could also check that clue, is it clue? I know I changed the name. Yeah, clue make dollar should be equal to that. Okay. And then wrong guesses make dollar should be B. Okay, does that kind of make sense? I don't know if this read stub contents, maybe this is read stub init. So this is really the guess, the answer. And so when we call game loop, we're going to tell it the answer. Is that useful? Maybe we don't need to tell it at that point, as long as we did game init. Right? I mean I think that's correct. Okay, so you've initialized with something. We set up some stuff for the stub to do guesses. We call the game loop. When it finishes, we should have the word right. The clue is the guessed total word. And the wrong guesses should have B in them because we guessed B first. And then that. Okay. So read stub, I think it's array. Let's give it 10 letters, read stub array. Okay, read stub init, and then read stub. Well, there's going to be more to it. It's not that, it's that. And this should say test game loop dot dollar arrow. Okay. Read stub game init, read stub init, read stub game loop, and then the asserts. Okay, and this is also init. Okay, so let's take this. This should fail. Good. Okay. That's the 3 assertions. Clue should be and And it's not. Okay, so it didn't do any guessing. The stack, this is probably Lily's. Or maybe it's some of our strings. Yeah, it's probably some of our strings that we still have piling around. Okay. Yeah. So I guess we got to make the read stub do its thing first. So read stub is init. I want to do read stub array string to array. Now I got to check the order on those things. String to array wants the string on top and then the array. Okay. So we're going to have to swap. Because we got the string coming in. Okay. Okay, so I'm going to write the stubbed values that we're going to get back into that string array, and then we're going to need an index var, var read stub index, and that should be set to 0. 0 read stub index at equal. Backwards. Okay, so that should set it up so that that array is ready to go. And then the read stub should and that leaves a 0 at the end. So read stub will do read stub array read stub index at plus, get the character, and then read stub index at plus plus. Okay, so increment this counter. All right, string to array. Yeah, okay. Right, so I think that should call these. Well, nobody's going to use it. All right, so it should still fail. I mean, definitely, we haven't touched the real stuff. We're just trying to get the stub right for starters. Okay, so test game loop blows up. Okay, good. So now game loop's got to do its thing. So game loop, so this is a while. We want to say while game over. Is that what we have somewhere? Now our game over isn't quite enough, but wherever it got off to. I know we have it. Game over. Okay. So we didn't say what that needs. The answer is guess. So we're not limiting your mistakes at this point. In none. Okay, we're not referencing the stack. We're using it, but we're not relying on anything being there because we're looking at a couple of variables. All right, so game over. If it's not over, do something and return. Okay, and then the read routine is on the stack. So does call? I don't remember. Does call consume that? I think it must. So let's do dupe call. And that's the read. Okay. And then we want to do update clue with that character. We give it the character. Okay, so update clue. Update clue. That gives us back a Boolean. If, let's negate the Boolean. If the answer was wrong, then we need to do our other thing. Update wrong guess. Yeah. And so we need the character for that. Read leaves a character. Update clue. Takes a character. Right? Yeah. Okay, so I guess we need to duplicate that character. Before we call it. That's wrong. Read drops one of these. Okay, getting there. All right, now update clue returns a Boolean. This is still a Boolean. And this leaves us with character and routine. Okay, update wrong guess wants a character, and it consumes it, and we're left with the routine on the stack. Now that something's wrong because we're I think else we just had to pop. Leave the routine on the stack. Okay. Yeah. Maybe we should flip that. Well, let's get it working, then we'll simplify it. Okay, so at this point, we have the routine on the stack, and we call game over again. So the routine is on the stack. Game over yields a Boolean. And that's a Boolean. Okay. And then this is okay. So at the end here, we have routine on the stack back up to the while, and we check game over with the routine on the stack as a stat, so that both paths give the same stuff. Which kind of reminds me, I work way early when I was consulting. I did a session with Ward Cunningham and some others, and I ended up riding on the bus next to Ward and just talking about all these things. And one of the things he talked about was writing assembly routines and that involved timing. And what he would do is he would take the if and the else, and if the if had a bunch of things in it, he'd make sure the else had the same number of no ops or whatever was required to make it take the same time regardless, you know, of whether the if or the else was true. So he could do timings without, you know, he could just add up the timing for this if statement is such and such, and made it all come out. I think we kind of are doing the same thing here, that we, you know, we have a condition going in and we're making sure the stack is the same, whether it's the if or the else. And the routine is what we need for our loop. So it works out. Yeah. Yeah. So, right now we don't show the hangman. Let's save that. I don't want to forget it though, because that does it is a good thing. Yeah, now it's a win every time. Print game over. Win or lose. Okay. Right, but this. Okay, my belief is this will do it. While the game is not over, call the read routine, get a character, do something with it to decide if we should update the wrong guesses or we've already updated the right guesses. Maybe that could be that maybe could be more symmetrical. And then we do that to print. Okay, so let's see how our routine does. From scratch. Okay. And the game loops in here, so no compiler errors. All right, so test game loop. We want it to pass. Okay. Rather than go into it now, let's just take our break. We'll come back in 3 or 4 minutes and we'll find out why our game loop is blowing up. All right, see you in a few minutes. Welcome back. All right, so perhaps update clues should be a mirror function and we need a check letter correct. Yeah, I think that would be better. Maybe it simplifies both of them a little bit and it makes a kind of symmetry in what goes on when you pass or fail. So, but let's get this working first. All right, so I don't know the best way to. Well, we don't know where we're dying, except it's probably in game loop because we didn't die in the test before. So maybe that's testable or checkable. Before and after. Okay. Yeah, so we're dying in there as you'd kind of expect. All right. So game loop. All right, I'm going to print before and after. Print and pop. If we run, then let's do exclamation. And down here. Print done. And then in here, let's print no. Yes. And maybe after this, yeah, I guess we'll be able to tell from that. Yeah, that's true. It shouldn't affect this test, but it could. Okay. Question mark exclamation. So we got in here and died before we could print yes or no. I guess that should be read as red. Okay. This is repeating. Well, we're dying quickly. Maybe it's our stub. Okay, we printed repeating, bang, and then somewhere between the dupe and the call. Okay, well, let's go check our stub. Read stub array. So the index should be 0. Well, let's take a look. Read stub array, make $print. And pop. Red. There's a line there. Okay. Make sure this thing is right. Yeah. Okay. All right, I don't know. We're annotating a lot. Read stub BA, that's good. I guess. Oh. We died before we could tell what character we read. Read stub array. Index at. Isn't that easy to leave off? Okay, cool. That's something. All right. So error values differ. Oh, so our stack's not cleaned up. Read OK. No. That was the B. Start the loop again. Read stub. Bear BA. Read 97. That's the A. Read OK. Yes. Repeating dot gets us out. Okay. Then I think we've left a string on there somewhere. All right, let's take this out, this out. Oh, the game loop probably needs to get rid of the stuff on the stack. It's kind of a loop invariant sort of thing. All right, so these both had routine. Wait. Yeah, character routine, and at the end of the loop, we need to pop. Okay. And then, I mean, we called it hangman here, but this is really, it's like hangman, draw hangman. Or it's game display. And I think we should do it in our loop. And this is where I'm not, well, I'm not sure. Maybe we need to pass. Maybe game display is its own thing. I think we need to pass two routines in. Read routine. It's not answer. Let's do display routine. Let's see if we can keep it straight. Okay, so that was game display. Game display. Oops. All right, and then, yeah, that should be popped at the end. Read display. All these routines are really read. Okay, but we're getting this on the end. And then here we have read display. So we need to do pop pop. We're not using it, we're just trying to get the stack right. Port not found. Okay, something's. Okay. Seems like an easy thing to do. Redisplay. Game over. Gets bool. Redisplay. Yeah, the game display needs to be called here. No, it needs to be called here. Okay, but what's the symptoms? This is getting overwritten somewhere crazy, which is weird. I mean, all we're doing is passing an extra argument and popping it. Okay, so read display, read routine, display routine. Okay, reads in front. Boolean read, Boolean read and display, duplicate, read, call, read, display goes to oh no, that was not a the stack becomes character read display, so the routine gets called, consumed. Okay, let's double check that call. So let's make this routine goes to ... Is that right? Because it pops this, doesn't push it back on, it just calls. Okay, so that does consume. All right. So what's going wrong here? I mean, it seems like that seems. Oh, that's update clue. Okay. Game lab. Okay, duplicate call calls read, returns character. So we have character read display. Duplicate the character, update the clue, detect what it said. Oh, wait a minute. Why was that even called? I didn't call it. Did I? I guess I did pass the real one in. But so this should say, what are you about to call? I would think it's got to be the read routine, the stub read. Did I get them backwards? Read stubs on top. Read routine, display routine. Okay. Yeah, that's okay. Oh, it did a bunch of things. Wow, crazy. Calling XM9. Okay. All right, what's going on? Read stub init. Good. Read stub is not on top. You're right. It is wrong. Okay, calling read stub. That's kind of progressive thinking we need. Okay. And then our test is really going to call, well, I don't know, we'll call it display stub, I guess, but it's doing nothing. Okay, so test game. Loop, good. All right. So I think now we can call the display stub. I want BAB gives me display read display, and then I call it and I get back to read display. Okay. This should still just do its thing. Okay. But if we put display in there, just for our own amusement, well, I guess I could just redo this. Now we're going to get some pictures. 2 of them, and we need 3. Word not found display. Oh, it's display game, not display stub. Game display. Probably need to print it once before the thing, right? Boom. Word not found, word not found. Oh, yeah. So something's wrong. Like that should really be AA at this point. Well, it should have shown it bad once. It should have shown this, and then it should have shown it again with everything right. But word not found that. That's really bizarre. Let's make sure game display and screen clear. Let's take that out so we can see what's going on. Draw at. He takes no arguments, right? So something's wrong. Some of these, we got to distinguish draw at from, there's one that draws the array of stuff and one that draws one line. Okay, so this is draw, and the hangman title is just a draw at. Clue is well, scaffold, yes. Wrong guesses is a string. That should just be that. Make $15 draw at. That should be okay. Now, really, it wants to. It kind of half wants to call draw at for this, but okay. I don't see it actually. Word not found. Empty X question marks. Something's out of bounds. Okay, I took the screen clear out, so it should just draw over it. I'm going to put a read in here just for debugging purposes. Read pop. No, that won't work, will it? It might. Nope. So red. We're not found read. Well, wait a minute. Read. Isn't that a language level word? No. Did we not publish it? Should be on our inputs. No read colon. Well, what do you call input read line? This is input. We probably want IO. Read getsy. Okay. I don't think we had any unknown words. Okay, and now if I do test game loop, it draws. Well, that's kind of annoying. It's waiting for me to type something. Wrong guess B. So I think that's displaying correctly. That's the underscores. There's the scaffold. Wrong guess B. I'll hit a space. And now I get word not found. Yeah, that's a good question. I mean, word not found would be executing something. Well, okay, it could be. I guess it could be somebody leaves the stack wrong and, which would probably be game loop, I guess, or something. But if the stack got left wrong, then when somebody tried to use the routine, they would find a weird name there. Is A or B left on the stack? Yeah, that's the real question. And I think not, because we have character here. Update wrong guess uses it. And then pop is popping the character. I mean, this string game display. I don't know. I guess I could put the screen clear back and not hurt anything, because now we pause when wait for a character to read. Okay, so we that looks good. That's the first one. And then boom, it's all over the place. Comma X, back quote, comma. Doesn't sound like anything I know about. Okay, so it seems like the first one is fine. It calls display. Excuse me, we have read display here. Theoretically, we want it here. Well, I guess we want it here. And then we have it here. Yeah. Well, let's print. Let's print the top of the stack. We'll get the character in those two routine numbers. And then here it's no. And we'll print those three things again. Update wrong guess. Let's make sure that consumes exactly one character. Update wrong guess. Takes character. That doesn't do anything. Cab swaps them around. Wrong guess is index at. We did that. Okay. Yeah, that seems okay. All right. Yeah. So this is a little weird that I would have expected something to come out before. Okay, word not found. Displayed. Okay, well, the stack 31923554, that sounds funny, right? If it's, which version is that? Loop, right? The stack should have a character on the top. Oh, our stub doesn't do that. No, read does. Okay. Let's call it 398. Well, that should be the read routine. Which is our dummy one for now. Read stub. And this read should put the character on top, but the character is not a character. If I've forgotten an at. Read stub array. I mean, we want the address of the array, then the index counter, which we have. Okay, so we should have the three things. Well, the bottom may be boring, but okay. 398, the call after printing displayed. Yeah, that should come around to the loop. We'll do all that, but it should be the read routine. Let's print that too. Okay, so we're waiting. Yeah, I think what's on the stack when we invoke call is going to be the interesting thing. Game loop right here, top of loop. Well, these should be three different things. Or two the same, one different. I guess I'm puzzled. Why? Oh, the screen cleared out the debugging stuff. Okay. Top of loop 24, 24, 76. Is that the read routine? Top of loop 24, 24, 76. So I don't know what that routine is. Different. Well, where's loop? 9776. See, these are 76, 76, 7112. Okay. That's more like it, I guess. But something's funny, right? Something, like if this is read, this is display, and yet somehow at top of loop we have display, and some other completely random thing. Yeah. Okay. Let's print the first one there. And then the three values. Yeah, if it's different, we'll see. Okay, so I'll hit space. Top of loop. Something's quite weird. Okay, so top of loop, between top of loop, it should have printed the string that was on there. Okay, so let's game loop red. What is that? some other random thought. Okay. So let's start game loop. And the top is supposed to be routine. And we'll do a swap and a dollar dot and a swap. Yeah, it doesn't seem like it's the right string somewhere. Okay, so this should print read routine and display routine. Actually, we only see the second time around, so that's kind of annoying. Test game loop. So already something's weird because we got a question mark. Let me do a get see here. Maybe I should do one here too. Uh-oh. Oh, that's my wait. Test game loop has game loop and read stuff. That doesn't sound right. Test game loop. What? So the top of the stack is game loop? Did I do a print that didn't actually print? Yes, I did. Okay. Sorry about that. Game loop, read stub, and game display. Okay, so that's the right routines. Read stub and game display. Okay, so then when we come in, all right, so I've got a get see there, so I'm going to hit space. Boom. Okay, so I'm doing something wrong in here, but those two routines were the right routines. So at least the right stuff's getting in there somehow. Let's track through these and make sure they are correct. So coming in, we have read and display. We need to make sure that at the odd, we have read and display. Okay. Game over puts a bool on top. Bang puts another, replaces it with a bool. The do consumes the bool and leaves us with read display. Read display. Call consumes the first read and puts a character there. Duplicate puts the character twice. Update clue turns the character into a boolean. Not boolean to boolean. If consumes the boolean. Update wrong reads the character, leaves us read display. Otherwise, this one is ch read display. And we pop and we got read display here. Bab makes display read display. Call calls display. And then we say displayed. Okay, I don't know where to. So they're on the top of the stack at the end of the loop too. Yes, they should be. So displayed that. Let's display top swap top, swap, new line. Okay, so that should... After the display, that should display this stuff and show us redisplay it coming back up to the top of the loop. Okay, so I should be able to do this line as well. And this is while. Yeah, I don't know. I didn't want to do the trouble to do a debugger, but this demonstrates it sure would have been helpful. Game, what is it? Test game loop. So read stub is the 4302992. And presumably 2944 is display. Oddly close to each other. Okay. Read stub S equals 0. Okay. Read stub. Why does our read stub get a 0 on this tag? Well, we haven't put anything there really. But after should have the character. Okay. So we read 98 first, that's B. Okay, so that seems okay. Loop has the character after the call, right? 2992 is read and 299444 is display. N, is that one of my things? Yeah, the no case. Okay, that's correct. All right, and then we're down to the get C before the display. Displayed, boom. Golly. 98 is the B. I guess I could display it here. But weird, right? It called displayed, but it doesn't appear to have drawn anything. Now, if this thing isn't a string, then trying to print it is going to be a problem. But let's print it here. After bab dot arrow. Wow. Arrow dot. Okay, we should see 3 routines, and they should be the same as the first 3 in the other order. Okay, so stub game, so it should be 144 is read. Notice they come in different places every time. I think that's a security thing. And 4096 is display. Okay, so we read our B. We're in the no case. We called after, wait a minute, after Bab for, oh, whoa, there's a character in there. A space? Yeah, it looks bad. I don't even know how a space, like where'd that space come from? It's not in our stub. I mean, we've had a no, we don't have a yes, right? So this is the first time through. We had if ch read display. Update wrong guess should have consumed that. Okay, we should get those same numbers there. But I think we're going to see CH in there. Yeah, let's check that. Update wrong. I don't think he returns anything. He writes, well, he gets the word guesses array. He gets the wrong guesses array. The wrong guesses index, reads that. Then he swaps, we have character coming in. So character's on the bottom. CAB pulls the character to the top. At plus equals should write the character to that position and leave nothing on the stack. And then word guess index update doesn't leave anything on the stack. Well, let's check that claim. Okay, so we have a variable on this stack, a variable address. We duplicate that. We look up its contents. We add 1. And then we store it into the variable. So that should empty out the stack. Yeah. Okay. But somehow we're getting a 32 in there. Like, where the heck is that from? All right, we'll do this. Okay, so top of loop, the read is 8920. The display is 8872. Consistent difference, anyway, 52 away. Okay, so after update wrong, we have 90, okay, the read in the display. Okay, so after update wrong, we have the read in the display, which is what we expect. Okay. Now I'll step after BAB. Okay, wait a minute. After update wrong, and then BAB. Update wrong had these two on the stack. BAB. BAB is supposed to copy the second item into the top. Is that not doing the right thing? Well, we can test that manually. Okay, so 3, 2, 1. 3's on the bottom. Dot, dot, dot. Oh, I don't have dot, dot, dot. 3, 2, 1, dot should have 1. Okay. If I do BAB dot, I should have a 2. And if I pop, I should have a 1. And if I pop, I should have a 2. Pop again, lilies. 3. Oh, yeah. 3, 2, 1, 2, 1, 2. Okay. And I pop dot 1. I guess we don't know what we have starting. Okay, 30, 20, 10 dot BAB dot brings the second one up to the top. Delete that. 10, yep. 20, 30. Okay. Yeah, I'm pressing space where we call get C. Get C reads. Oh, did I not pop it? You're right. There's the space. Okay, where's the other get C? Okay. Yeah. Finish shooting myself in the foot. Okay, so read stub. Oh, the index, I guess. Okay. Top of loop read stub is 6624's read. 6576 is display. Okay, that's that. Update wrong. 624. I don't know what. Oh, that's read. Read, display, and the bottom. Okay, after update wrong. Okay. So we should come out with read display. I'll hit a 0 this time. Okay. Wrong guess is B. So it called our display method. Okay. And now we're in, where are we? I guess we're in the loop again. Pop. Is there another get C? Okay, return. Okay. All right, so displayed after call should be read display. I don't have a displayed up here. Well, they're trashed. After Bab. Oh, I lost. There's after Bab. 76 is display, read, display. Okay, and the call should consume that and leave read display. Okay, so this to me is very weird. We got after bab, we've got um the display read display, which is what we want. We call the top thing, which does the display, that's fine. We get back and we say displayed, and like he's chewed it up. $. Swap. And this should print them. Should print the value on top of the stack as a string, which it should be. Something gets trashed. I mean, that's all there is to say. And then word not found. That's probably our call routines going like, yeah, what's X? Bang, question X. All right. Well, I hate to finish 2 days in a row with a defect sitting there, but we've got something going wrong here. It maybe call is not acting the way I thought. But like, why would it blow up reading this string? Oh, it doesn't. It doesn't blow up. It just looks like a weird thing. All right, I'm going to try one more thing. I'm going to do a ... displayed number ... Okay, so see what those are coming out as, and then we'll call it a wrap, I guess. Out of time. Make REPL. Hard to leave a bug alone. All right. Okay, so 9056 is read. 9008 is display. Okay, after update wrong, read display and guard word. Okay, I'll hit return. It runs. So it's calling display, wherever call is. Now, why don't we get after bab first? Maybe we don't get it at all because we read past it. Displayed is 3544 2896 832. Totally random weird stuff. All right, well, that gives us something to contemplate tomorrow. Well, anyway, thanks for today. We got through one bug, got a little bit of progress. I mean, game loop is kind of the whole thing, right? The rest is displaying those characters is probably not too hard. Is the display routine messing with the stack somehow? I don't think it's supposed to. I mean, dot is not supposed to. Dot string is not supposed to. Dot string pop does. But these two are just plain dot strings that say, look at the top of the stack. And they should be harmless. Now, the two swaps fools with things, but if they're wrong before this, then something's off. So I don't know where that means is off. I mean, we couldn't really see this one because of the position of the character. Maybe I should move this down and read it after we've said what the display is, call and read it again. Like those two things should be, it should be whatever this number is here, and then just two things and it's probably 90210 or something on the stack. And if they're not doing it there, okay, and then maybe another getC. Okay, so that'll give us somewhere to pick up. Game display. Well, I mean, again, it's not supposed to. I mean, game display is this. He's really, basically, he's drawing stuff and waiting. I don't know. I think this getC pop can probably come out. Okay. But yeah, I mean, in principle, he's not supposed to be screwing anything up. So we shall see. All right. Take care. 2 to 4:30 Eastern and 6 to 8:30 p.m. UTC. Have a good night. Bye-bye.